when multiple grounding rods are used as part of a grounding electrode system. National Electrical Code Section 250.66 still applies. This section dictates the minimum size requirements for the grounding electrode conductor. The grounding electrode conductor connects the grounding electrode, in this case the multiple grounding rods, to the equipment grounding bus or terminal bar within the electrical service equipment. The primary purpose of the grounding electrode system is to provide a path for fault current to return to the source, facilitating the operation of overcurrent protective devices like circuit breakers or fuses, and to stabilize the electrical system with respect to earth ground. When dealing with multiple grounding rods, it's essential to understand that their combined effectiveness contributes to lowering the overall grounding resistance. Ideally, the goal is to achieve a grounding resistance of 25 ohms or less, as specified by the NEC. However, the size of the grounding electrode conductor is not determined by the measured grounding resistance, but rather by the size of the service entrance conductors. According to NEC 250.66a, if the service entrance conductors are made of copper and their size dictates a grounding electrode conductor larger than 6 AWG, then that larger size must be used. However, the code allows for an exception. Even if the service entrance conductors would normally require a larger grounding electrode conductor, the grounding electrode conductor to ground rods or ground plates does not need to be larger than 6 AWG copper or 4 AWG aluminum. Therefore, the minimum size of the grounding electrode conductor when connecting to multiple rods is 6 AWG copper or 4 AWG aluminum. Here is a breakdown of the key considerations. Firstly, code compliance. Always adhere to the latest edition of the National Electrical Code, specifically Article 250, which covers grounding and bonding requirements. Secondly, grounding electrode system. Multiple grounding rods are typically used when a single rod fails to achieve the desired grounding resistance of 25 ohms or less. The NEC requires a supplemental grounding electrode, such as a second ground rod, if a single rod measures higher than 25 ohms to ground. Thirdly, grounding electrode conductor size. The size of the grounding electrode conductor is determined by NEC 250.66, which references the size of the service entrance conductors. However, as mentioned, there is a provision that limits the size of the grounding electrode conductor when connected to ground rods. Fourthly, material type. Grounding electrode conductors can be made of copper or aluminum. The NEC specifies the minimum size for each material. The minimum size for copper is 6 AWG and the minimum size for aluminum is 4 AWG when connecting to ground rods. Fifthly, installation practices. Ensure that the grounding electrode conductor is properly connected to the grounding rods using approved connectors. The connection should be mechanically sound and electrically conductive. Also, protect the conductor from physical damage where necessary. Sixthly, inspection requirements. Electrical inspectors will verify that the grounding electrode system complies with the NEC. This includes checking the size and material of the grounding electrode conductor, the type of connectors used, and the overall installation. Seventhly, continuous length. The grounding electrode conductor must be a single, continuous length without any splices or joints. Splices are only permitted if they are made using reversible compression connectors listed for the purpose or by the isothermic welding process. Eighthly, protection from damage. Where exposed to physical damage, the grounding electrode conductor should be protected by rigid metal conduit, intermediate metal conduit, rigid non-metallic conduit, electrical metallic tubing, or cable armor. Ninthly, connection to electrodes. The grounding electrode conductor must be connected to the grounding electrodes in a manner that ensures a permanent and effective ground path. Use listed grounding clamps or connectors suitable for the specific type of grounding electrode. Tenthly, resistance measurement. While not directly impacting the conductor size, measuring the grounding resistance is crucial. If a single grounding rod does not achieve 25 ohms or less, a second rod is required, and they should be placed at least 6 feet apart. Additional considerations are as follows. Supplementing grounding electrodes. If the initial grounding electrode system does not meet the 25 ohms resistance requirement, supplementary grounding electrodes must be installed. These supplementary electrodes should be spaced at least 6 feet apart. Common materials for grounding electrodes. Grounding electrodes are commonly made of copper or copper-clad steel. They must meet specific requirements outlined in NEC 250.52. These include minimum dimensions and material specifications. Installation depth. Grounding rods must be installed so that at least 8 feet of the electrode is in contact with the soil. The top of the rod should be flush with or below ground level unless protected against physical damage. Approved connection methods. Connections to grounding electrodes must be made using listed connectors or clamps that are suitable for the materials being joined. These connectors must be resistant to corrosion and provide a reliable electrical connection. Grounding electrode system bonding jumper. If multiple grounding electrodes are present, they must be bonded together using a grounding electrode bonding jumper. This jumper ensures that all electrodes are at the same potential, improving the overall effectiveness of the grounding system. Size of the grounding electrode bonding jumper. The size of the grounding electrode bonding jumper must comply with NEC 250.66, which typically requires it to be the same size as the grounding electrode conductor. Inspection and testing. After installation, the grounding electrode system should be inspected and tested to verify compliance with the NEC. This may involve measuring the grounding resistance and inspecting the connections to ensure they are secure and properly installed. Documentation. Maintain records of the grounding electrode system, including the location of the electrodes, the size and type of grounding electrode conductor, and any test results. This documentation can be helpful for future maintenance and troubleshooting. Ground clamps must be made of material suitable for copper, and there must be no chance of corrosion. It is also good practice to label the grounding electrode conductor and the grounding electrodes to identify them clearly. This helps prevent accidental disconnection or damage during future work. Continuous improvement. Regularly inspect and test the grounding electrode system to ensure it remains effective. Over time, soil conditions may change, affecting the grounding resistance. If necessary, add additional grounding electrodes or take other measures to maintain a low resistance ground path. By adhering to these guidelines and best practices, electricians can ensure that grounding electrode systems are properly installed and maintained, providing a safe and reliable electrical system. When installing multiple grounding electrodes, it is important to ensure proper spacing between them. The NEC recommends a minimum spacing of 6 feet between electrodes to minimize the overlap of their effective zones in the soil. This spacing helps to improve the overall effectiveness of the grounding system. Also, proper selection and installation of connectors are crucial for ensuring a reliable and long-lasting grounding system. Use listed connectors that are specifically designed for grounding applications and follow the manufacturer's instructions for installation. Also, consider the environmental conditions when selecting connectors, as some connectors may be more resistant to corrosion than others. Periodic testing of the grounding electrode system is recommended to verify its effectiveness. Use a ground resistance tester to measure the resistance to ground and compare the results to the NEC requirement of 25 ohms or less. If the resistance is too high, additional grounding electrodes may be needed. Furthermore, documenting the installation and testing of the grounding electrode system is essential for future reference and maintenance. Keep records of the location of the grounding electrodes, the size and type of grounding electrode conductor, and the results of any tests performed. This information can be helpful for troubleshooting and ensuring that the grounding system remains effective over time. In addition to the NEC requirements, local codes and regulations may also apply to grounding electrode systems. Be sure to check with the local electrical inspector to ensure compliance with all applicable codes and regulations. Lastly, proper training and education are essential for electricians who install and maintain grounding electrode systems. Stay up to date on the latest NEC requirements and best practices, and seek out training opportunities to improve your skills and knowledge. This helps ensure that grounding electrode systems are installed correctly and safely. In summary, when using multiple grounding rods, NEC 250.66 still applies. Ensure the grounding electrode conductor is at least 6 AWG copper or 4 AWG aluminum, following all NEC guidelines for proper installation and maintenance.